This one should work now. The mic should be working. Tell me it's working. Hello? Please tell me it's working. I think I've got it sorted. Refresh. And tell me it's working, please. Yes, audio is good. Whew. Hello, hello. How's it all going? Shaky start. Literally, my cable wasn't plugged in enough. That is all that happened. It works, mate. Good, good, good. We got a couple regulars in the chat. We got a couple people. I've written some stuff on the side here to premise what we're doing. First things first. Hope everyone's doing well. My viewers are at 0 right now, but I don't think that's true. Hope everyone's doing well. Hope everyone's ready to learn hard out. I was almost going to buy a new webcam, but then I just ran out of time. Next stream, almost guaranteed new webcam. I've got a bit of extra dosh lying about because that's life, and so I'm going to buy one. Nah, Mihi's in the chat. Okay. First things first, exclamation test in the chat to get oh, who am I? Exclamation test to get the test paper in the chat. I'm Mr. Benson. I'm a teacher. I'm covering the level 2 calculus end of year exam external. We're doing 2016 paper because I did 2017 in class today. So 2016, did 2017 today, 2016. I've got the questions. I've also got the answers here. I've also done a couple of the excellence questions right about 5 minutes ago to make sure I can do it alright. Okay, I will link this in the chat. Oh, I will link this. This is all the NCEA stuff about in calculus. All the NCEA stuff about calculus. So that's a good place to start. As per usual, don't take everything I say for straight fact. Listen to your maths teachers and all the people you trust more than me. They know more than me almost always. And as per usual, exclamation form to do the form. There is a form that you can do in the chat. It would greatly help me understand how these things go, whether it's good, bad, and ugly. That would be awesome. We'll do it at the end too. Right. Firstly, I'm not going to teach basic differentiation, basic anti-differentiation. I'm premising that you should know how to do this. If you don't, you are quite far behind, and you will need to do lunchtime tutorials or after school, things like that, to learn the basics before we do this. Okay? The other premise I want to do is this stuff. This is what I teach my class. The type of questions in a calculus exam. Okay? So we have like 1, 2, 3, 4, 5, 6, 7 types of questions. One is find the gradient, find the coordinates, equation of obtaining max, blah 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 blah. Okay? This is important to know because each type of question has a different reaction. So we react differently to each type of these questions, and I'll be highlighting this as we go through. The other thing I want you to know is this there. How long is the stream going to be? Probably a couple hours. We'll see how we go. Okay. The other thing I want to highlight is these facts here. TP, turning point at y dash is 0. Y dash is the gradient. I should write that here. Y dash equals gradient. I cannot stress that enough. Y dash is the gradient. Okay. Right. Turning point at the gradient of 0. Y double dash, the double derivative test. This way is a minimum. If you tilt this to the right, that's the shape it is. If you remember. If you imagine tilting the less than sign to the right, it's going to look like a minimum. Tilt this to the right, it looks like a maximum. That's a funky way to remember. These are the facts that we should know, and I highly recommend writing this on your test paper as soon as you get into the exam. Okay. Right. Is there any last things? Not really. Last thing I recommend is having a pen and paper in front of you and doing the test questions with me. It's going to be far more beneficial for you if you do it with me. Remember, you can create a free account with Twitch and ask questions in the Twitch chat, which will make me respond. I can read everything in the Twitch chat. Don't be inappropriate, and we will be away laughing. I think that's everything. If you guys are ready to go, spam the chat with something exciting. Get your pen and paper ready to rumble, and let's do it. Ripped off my first question, my first piece of paper. What I was thinking of doing is going through all the achieved merit questions and then at the end hitting the 5 or 6 excellence questions at the end. That way we can whiz through the start and then we'll crack into the depth stuff, and if you're unable to grasp the hard merit questions, there's no point staying for the excellence part. And if you, yeah, that's probably the easiest way, rather than going easy, medium, hard, easy, medium, hard, easy, medium, hard through the 3 big questions. So I'm going to skip the E questions till the end, but we should be able to get through this. Cool. Right, let's do it. Question number 1, a function f blah 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 has all this blah blah blah. Find the gradient of the graph of the function at the point where x is 2. Okay, the type of question is a find the gradient question. I know that because it says find the gradient. Okay, the way we react to find the gradient questions is we diff and sub. If you're ever in doubt, you should just diff and sub everything you see in the test paper. You'll most likely get a better grade than if you didn't. Okay, plus 2x minus 4. Tell me if my handwriting's small, tell me if I'm talking too fast or if I sound bad in the audio. We differentiate this, f dash x equals 12x squared minus 14x plus 2. Times by the power, take 1 off the power. Cool. Find the gradient of the blah 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 where x equals 2. If x equals 2 and we want to find the gradient, we're not going to touch this side and we're going to substitute 2 for x because x equals 2. So we have f dash x, or we could even say f dash 2 if you want to be fancy. 12 2 squared minus 14 2 plus 2. Now at this point I don't trust my maths, so I'm going to just type it all into the calculator. 12 2 squared minus 14 2 plus 2. The gradient at the point 2 is 22. Done and dusted. Yes, I'll have a VOD after the stream. It'll either be on here or on YouTube. Probably on YouTube as well, because it is an external. And you might want to view it later in the year for mocks and everything. Okay. Right. Let's see if we got that one right. 22. Easy peasy. Achieve. Not too hard. If there's any questions, now's your time to ask. Diff and sub. Diff and sub. That's how you answer most of these questions. Next one. Let's go hard and fast. Right, the line blah 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 does this. The line, okay, let's actually read it. The line y equals x plus 3.5 is a tangent to the graph of this. Use calculus to show that this is a tangent. Oh, I get excited by this because firstly, it's an equation of a tangent question, which is not too bad. This was A leads to B. Okay, can't see the question. Oh, let's move my stupid dome. Hold on. Webcam. Let's move that down there. Let's move that even. Oh. Oh, I'm floating around the page now. Let's put that there. Oh. Is that? That looks reasonable enough. Put that. Oh, let's just get rid of this. What is this? Oh, it's there. Where's my webcam gone? There we go, there we go. Oh, everything's moving around the page. Can you turn off the up dog setting on OBS? Mate, you think I'm born yesterday, eh? Let's move this one. Oh no! I don't know if I can undo that. Holy smokes. Oh, let's just delete that. Yes, sweet. Okay. That's a bit better, isn't it? Okay, thanks for the heads up. There we go. Oh, spaghetti got baited. Right. Here's our question here. We're off to a rickety start in terms of the thing. Right. Let's time that out. Okay. This question here. We get excited because it is it is an equation of a tangent. And what we think of right away, or what I think of right away, is this formula here. Y minus y1 equals mx minus x1. Okay, and the reason why I really like this question is because it's saying here is the answer, show that this line is the answer, show that this is an equation of the tangent and that it is correct. So I know if I've got it right or wrong because I should end up with that as my answer. Okay, so let's have a look. F of x equals 3x squared minus 2x plus 4. Okay, what's the YouTube channel? Exclamation YouTube rules and you will see. F dash x, I'm going to diff this, 6x minus 2. And then I'm going to sub. Now, it gives me information that I can sub. It tells me 0.5 and 3.75. This is x and this is y. So I'm going to sub in 0.5 for x and I will find the gradient because that's the piece of information I'm missing from over here. Okay. F dash 0.5 equals 6, 0.5 minus 2. Six times a half is 3, minus 2 is 1. So I'm going to call this m equals 1. My gradient is 1. I agree with that because the gradient in here is 1 if you've noticed. Okay, let's write our equation. Y minus y1 equals m x minus x1. Let's move all this stuff out my way. Right. Y minus, for y1 I'm going to write this, 3.75. M is 1, x minus, and x1 I use this, 0.5. Now most equation of a tangent questions I'd be done. But I'm not done because it says prove that this is the answer. And we're almost there but not quite. I need to rearrange this equation to make sure it looks like that. So y minus 3.75 equals, expand this 1. 1 times x is 1x. 1 times 0.5 is minus 0.5. And then I'm going to move this minus 3.75. Y equals x. 3.75 minus a half. 3.25. And would you look at that? This looks exactly the same as the question. Nice. It means we have got it correct. That means I'm guaranteed to get that merit question. And I know it's a merit. Boom. Merit. If I just differentiated and subbed and found my m, then I get achieve anyway. Nicely done. So far so good. Right, let's have a look at this one. I think this is still a merit. Oh, yeah, still a merit. Okay. Wiping this screen. We're going nice and fast. Tell me if I'm going too fast. We've got a lot to get through. You have 3 hours to do this exam along with one other external if you're in 12B or 2 other externals if you're in 12A. Okay, let's do this question. Post your questions if you have any as we go. Right, let me know if there's any issues or anything like that. Easy A, easy M to be honest. Right, f of x 2x to the 3 plus kx squared plus 5. Now me and Mr. Singh have been chatting heaps and we both think there's going to be lots of letter questions in the exam at the end of the year. Okay, so you should get super used to them, and the best way to get used to them is by doing 1,000 of them. Okay, so here is one to add to your 1,000 that you're going to do. We have a min at x equals 1. Find the chords of the max. Oh, nice. That's a nice easy one, because we know for max and min type questions we have to double diff eventually. That's my automatic reaction. But let's have a look. Or let's actually write our facts up here just as a reminder. Y dash equals 0 at turning point. y double dash is greater than 0, which is a min. Y double dash this way 0, therefore max. I've just written my facts. If you're in my class, you should know these. If you're not, you should learn these. Okay, especially this one will help us. So let's diff it, because we're doing calculus. We know we're probably going to have to diff stuff. 6x plus 2kx, almost forgot the squared. So far so good. Right, the problem is this k. Right, that's the problem. And that's why they've given us this extra piece of information. It has a minimum at x equals 1. So we know minimums occur at turning points. Right, if I plot something, a minimum is at this point here. Right, if a minimum occurs at x equals 1, like it does in this picture, then I can say it's at a turning point and the gradient is 0. So I've set that to 0. The gradient is 0 at a turning point. I also know that x is 1. So 0 equals 6. 1 squared plus 2k 1. And now I've got one equation, one unknown. My unknown being k. So I can solve for k. 0 equals 6 plus 2k minus 2k, or it's probably not the best way, minus 6 equals 2k minus 3 equals k. We divide by the 2. Right, this is where we just got to be real good at algebra. Right, tell me if I'm going too fast. K is minus 3. So far so good. If k is minus 3, we can put it back into this thing here. F dash x 6x squared minus 2, plus 2 minus 3x. Let's simplify this first. Minus 6x. Okay. And we know we want to find the maximum, and the turning point y dash is 0, so we're going to make this side 0. 6x minus 6x. And we can solve this on our calculator, which is awesome. So, anytime you have what's called a quadratic, this thing here, x to the power of 2, something is something, we can go to our graphics calculator and solve it. Oh, worst student 2018 has already solved it. That must mean he's working from home, which is awesome. So my a, look, you can look at this here, it's sort of like a program. My a, that's the coordinates of the whole answer. I think that's the coordinates of the minimum, mate, because you got 1. You want the coordinates of the max. Worst student. Doing your name proud. So x is 1 or x is 0. X equals 1 or x equals 0. I know that the minimum is here because it's told us. Right? That means this must be the max. I don't need to do much else with that. I need to find the y value. I know that this one's a min, therefore this one must be a max. I could prove it by double diffing if I wanted to. Should I do that real quick? F double dash x equals 12x minus 6, and we sub it in, it would equal minus 6. Well, let's do the math properly. Which is less than 0, therefore a max, because of this information up the top right hand corner. There we go, 0, 5 looks better. Okay, so our x value is 0. To find our y value, we've got this original equation way up here. That tells us f of x, which is the same as y equals all that stuff. Y equals 2x3. K is minus 3. X squared plus 5. And for all the x's, I can write 0 instead, which is a nice x value because we can quickly do the maths. All that stuff's going to be 0. Y equals 5. Easy peasy. 0. 5 is our answer. There is a maximum at 0.5. Okay. Right, so far so good. If there's no questions, maybe we will just start doing the E questions, because there's not heaps of people in here. So it might be people that want to focus on E. So I'll just wait for the chat. Let me know if you want to focus on E questions, and we can just target the E's and skip quickly through the achieved merit. Or if you want us to go slowly through achieved merit, post in there as well. Okay, I'll wait a little bit, because I think this is starting to get into the excellence questions up here. So if you want to do E, just post I want to do E, or just post an E. If you want to focus on AM, just type in an A or an M, and we can go from there. Post that now. I'll have a quick drink. I can relax a little bit. Spaghetti wants to go. See you later, Spaghetti. Tim wants the fat E. Oreo SV wants the E. That's 3 out of way more viewers than 3. Nah, Mihi wants the E. I'm going to wipe this and clear my paper. Big fat E boy. Okay, most people saying E. I haven't seen any A or M's. So let's tackle the E questions. Maybe we can just skip over the easy achieve stuff and tackle mainly the E's and call it early night, play some games or something. Okay. Nutshell wants E2. Right, let's look at this one. This is quite tricky. I think 2016 was a hard paper. Right, so if we can smash 2016, then we should be away laughing. Right, the equation of a function y equals f of x has a gradient function in the form of this, where a is a where a is a constant. NCEA, just trying to think. Okay. Right, the point 34 is a turning point on the graph. What do we know about turning points? Let's write it. 34 at f dash x equals 0. We know that, right? There's a turning point at f dash x is 0. Okay. Well, worst student's already done it. Find the equation of the function. Right, we've been given f dash x. So we know we're going to have to anti-diff, which is the opposite of differentiation. Right? We've been given f dash x. If you're ever given f dash x, chances are you have to anti-diff. Okay? So f dash x equals 2x minus a. My a's look like 9, so let's be careful. Right? 2x minus a. Maybe I'll just point this a little bit this way. Okay. Therefore, if we anti-diff it, f of x will be 2x squared over 2 minus ax plus c. Okay, so we're on some sort of a track. Right? Now we also know that there's a turning point at 3, 4 when f dash x is 0. So let's use this piece of information over here and go, if f dash x equals 2x minus a and f dash x equals 0, then I can say 0 equals 2x minus a. Hopefully that makes sense. Right? We also have this bit of information here about the x and the y. So if 0 equals 2x minus a and x is 3 at that point, then we can say 0 equals 3 minus a, which means 0 equals 6 minus a, minus 6 equals minus a, which means a equals 6. Right? Is it possible to study math and chem at the same time? For sure, but chem is way worse than maths. Chem is for losers. No, I shouldn't say that. Chem is fine. I just don't like chemistry. Right? A is 6. So far, so good. Okay, let's even rewrite this thing over here with our A being 6. I want to get rid of that A as soon as I can, because I don't like other letters in there. So, our new f of x is, I'm going to simplify this 2 over 2 to make it x squared minus 6x plus c. So far, so good. Right, x squared minus 6x plus c. Now what is c? Well, we've got some information about the graph. It goes through this point here. So let's put 3 and 4 into the graph and see what happens. 4 equals 3 squared minus 6, 3 plus c. One equation, one unknown. Now we can find c. Okay. 4 equals 3 threes are 9 minus 6 threes are 18 plus c. 4 equals, this must be minus 9 plus c. Move the 9 to the other side. 4 plus 9 equals c. 9 plus 4 is 13. And now our final answer, we rewrite this including c. F of x equals x squared minus 6x plus 13. Easy peasy. Let's see if we got the right answer. Worst student was a little bit off. X squared minus 6x plus 13. Can be left as c equals 13. Oh man. We went a little bit of the extra mile. I reckon they changed that because people just got there and they needed to make some people get excellence or something. Okay. Not too bad. Just doing this little side work was the tricky part. Okay. But not too bad overall. Right. Let's see if we can crack the second E question. Find the local min value of this function. Now I highly recommend doing this with me. I highly recommend doing old papers before Monday. I've seen the test. That's my recommendation. Okay. Local min. Every excellence question so far has been like min and max stuff. Cool. Y equals x to the 3, x minus 4. Oh, this is going to be a bit funky. Okay, find the local min. That's all the information we've got. Easy peasy. We know we're going to diff. Okay. Pardon me. So, to be able to diff this, we need everything written as separate terms. Right? At the moment, we've got it as like a multiplication. So, let's expand this x to the 3, x to the 4, and minus 4x to the 3. If we expand that like that, then it's going to make our differentiation easier. Okay. Jeff from Kmart, thanks for the host, my dude. Thanks for the host. We've got Jeff from Kmart also. Oh no. Daniel Lord followed. Some other people followed. Thank you, worst student. Okay. Get my math when school starts. No way, dude. Okay. This is our equation so far. Now we know we can definitely differentiate this. 4x to the 3 minus 12x squared. No problem. Free data, let him come to NZ. Okay. We've got y dash. Now let's look at our facts. Turning point at y dash equals 0. So 0 equals 4x to the 3 minus 12x squared. Now this looks a little bit funky, but it is an excellence question, so we're expecting something like that. Right? So that's not what I want. I want this one. Let's look at these. So normally when we go to polynomial, it's x squared bx plus c. And this one we've got x to the 3. Don't worry, we've got degrees 3 in our calculator, and it looks exactly like that. Right? So let's have a look. So right now we've got 4x to the 3, and we've got minus 12 x to the 2, a 0x, and a 0 added on the end. Okay, these two terms don't actually exist, so we call them 0. Let's solve this. Look at this. So we've got 3 times 2, oh no, 3 and 0 times 2, so x equals 3, or x equals 0, or x equals 0. Those are our 3 terms, or our 3 possible solutions. Right, and we need to find out which one of these is a local minimum, is the question. So the way we test that is through the double derivative test. I'm running out of room on the page, so let's make it fit. The double derivative test. We're going to test this one. We're going to test this one. And x equals 0, x equals 0, doesn't really matter. So y double dash is 12x squared minus 24x. Okay. Right. Double derivative test. Good, Raina. So now we put in 3. Y double dash equals 12. 3 squared minus 24 to the 3. So far so good. And if we chug this all into our calculator, we get 12. 3 squared minus 24 to the 3 is 36, which is greater than 0. Therefore this is a minimum. Oh, not too bad. Let's double check this one real quick, just for fun, because I'm a nerd. I like to do this. Y double dash equals 0. Okay. I will quickly explain this because I think we've got some smart people in the chat. Right, we have y double dash greater than 0 and y double dash less than 0. This is a min and this is a max. Right? Mute. Done. Okay. This is a min, this is a max. If y double dash equals 0, this is called a point of inflection, where the graph, instead of going like this, it sort of goes like this. I'm not very good at drawing. I think. Oh, I'm not good at this. It's like this weird flat point. Oh, I can't draw it. We could plot it if we wanted to. Who cares? Right? All we need to know is that it's a point of inflection. It's just got a fancy name. Okay, but you shouldn't come across this very often. And we answered the question already over here. Okay, if you're interested, plot this into Desmos and see what happens. Plot this into Desmos. Okay, let's check we've answered the question. So find the local minimum value. Okay, so we need the coordinates x and y. So we've got the x coordinate. Now be careful not to use the y double dash coordinate. Well, it's not even a coordinate. Right? So double dash is used to the maximum. Double dash is used to prove whether it's a max or a min. Oh, it says max dash min. I read that as max and min. Right, exactly. Double dash is used to prove whether it's a max or a min. Alright, rules well done. To check it. Yep. So, we've got this. I'm going to work in this column without this thing here. Right. Why is it called a local minimum and not minimum? Let me show you. Sort of nice little sidetrack. If we go like this, it's sort of hard to see there. Raina, remind me in 2 minutes and I'll answer the question on a blank piece of paper. Okay? Let me just finish this off real quick. We've got our very original equation, y equals, I want to do the simplified version, minus 4x. It's not just because mathematicians want to sound cool, I promise. Y equals, and I'm going to substitute in this x value. 3 to the 4 minus 4, 3 to the 3. That's a big ugly thing. So 4, oopsies, 3 to the 4 minus 4, 3 to the 3. Y equals minus 27. So our coordinates are 3 and minus 27. Let's double check we haven't made any mistakes. Boom. So our excellence is confirming x equals 3. So solving this quadratic, this to the power of 3 quadratic, then justify with reference to the graph, or the gradient, or the second derivative, which is the test we did. You could do these other methods to check whether it's a max or min. So that's what rules was talking about, whether one's a max or a min. You could reference the graph by drawing it. You could find the gradient on either side, which I find confusing. Second derivative test, I just memorize those rules and it's fine. Okay, Now, that's our answer. Excellence. 2 E's so far. We've got E8. We are awesome. E8. We are fantastic. Right. Rainer's question was, why is it called a local minimum rather than just a minimum? I will show you right now. If you had a graph that looked like this, okay, and this went up forever, right, and here's the x and y axis, okay, if we had this locally, like in this circle, if you imagine me just looking with that circle of view, is a minimum, and locally this is a maximum, but globally, according to the whole thing, it's not actually the minimum point of the graph. Down here is, right? Down here is technically the minimum. Okay? And way up here, it goes off forever, it goes up forever. Those go up to maximums forever. Oh, I can't reconnect my lines. Those go up as maximums forever. But locally, just looking through here, this is a minimum. And you would say, locally this is minimum, but you could also call this one the global minimum. I think that's the term for it. Hopefully that makes a bit of sense. Here's my drawing. Nicely done. Right, it's funny how you can fail the A and M questions yet get the highest grade. Yes, I agree. It is funny, and also it is something we can use to our advantage. Right? You can target the achieve merit questions to smash them. It's sort of the theory is if you can answer the E questions correctly, doesn't matter if you can do A or not. Right. I'm going to skip this one. I don't like these sort of questions. They're only worth achieve or merit. I think this one's achieve. I don't really care. Let's move it. You can get excellence without even trying. Right. Done dusted. The line A, x plus b is a tangent. Should we try this one? It should be very, very quick. Let's give it a go. Right. Y equals 2x squared minus 3x plus 1. It's another equation of a tangent question. Okay, another equation of a tangent question. It goes through 2, 3. And it just wants us to shuffle it in a funky sort of way. Right? But who cares about this thing? Let's just do what we know about equations of a tangent. Y minus y1 equals mx minus x1. Right? Okie dokie. Let's diff it because we know we probably have to. 4x minus 3. Let's sub because that's always a step we do after we diff. Y dash equals, oh my gosh, 4, 2 minus 3. I've used the 2 from this x and y value here. Okay. Why not y equals mx plus c? I like this way more. That's the only reason why. You can use y equals mx plus c if you want, but I just prefer the y minus y1 way. In this question it probably makes more sense to use y equals mx plus c, but you can rearrange this and it is the same thing. So I'm going to use this way. Okay? If you've done it before, you can have your mind opened up to a new method. Y dash is 8 minus 3, y dash is 8765. Right? This y dash, remember y dash is the gradient, so this must be m. We use our formula y minus y1. I'm getting the y1 from here. 3 equals 5x minus x1 from there. 2. I've got a really itchy elbow. Right? Oh, y minus 3 equals 5x minus 10. Right? The only reason I'm carrying on with this, so this is the answer, but the only reason I'm carrying on is because the question actually asked for A and B. So I'm going to keep shuffling around a little bit. Yeah, we can already see A is 5, good. And we can do y equals 5x minus 10 plus 3, y equals 5x minus 7. Right? And we have to write the answer. Don't just leave it like that. You've done all the work without saying A equals 5, B equals minus 7, and getting the credit for it. If you do that, boom, easy merit. Ah, look, they're nice too. They can be expressed like that, but you should write it as, you should always answer the question, right? Okie dokie. Next one, C is another merit. We'll give C a go because there's lots of letter questions everywhere and it's not too tricky. We can do it nice and fast. Again, tell me if I'm going too fast. I talk fast. I want to get onto the excellence questions because I think we've got mostly merit excellence trying students, if that makes sense. Or students that understand the achieved stuff already and want to try the harder stuff. Right. Will I disappoint if you don't know how to use? No, not at all. Worst student is right. Worst student is the best student right now. It doesn't disadvantage you. They're both the same thing. You can rearrange this equation up here to be y equals mx plus c. It's the same thing. I just prefer my way. Well, it's not my way, but okay. Let's differentiate f dash x equals. Now they've tried to trick us by putting it around the other way around. Okay, but no, this 2 is going to disappear, and this minus 4x becomes minus 4 plus 10x plus 3ax squared. Right, this question was in the last test we did, and lots of people mucked up that minus 4. Lots of people. Read carefully, work slowly. Okay. The graph, the gradient of the graph function where x, okay, the gradient of the graph, blah 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 blah, where x is 1. So they word this so complicated, but they're saying the gradient of all this crap where x is 1 is 3. You could literally get rid of all that information. If you cover that up right now, imagine it's covered up. I've covered it up with my hand. The gradient is 3 when x is 1. So let's say at x equals 1, y dash is 3. Look, I can use 5 symbols and get this whole line of information. NCEA is stupid, but they haven't tricked us. So y dash or f dash x is 3 at minus 4 plus 10, and instead of x I'm going to write 1 because they've told us that, and we're going to find a. 3 equals minus 4 plus 10 plus 3a. 3 equals minus 4 plus 10 is 6 plus 3a. Minus 3 equals 3a. A equals minus 1. Okay. Dokie. Oh, that's the question done. Answered. Easy. So my handwriting gets smaller and smaller as we move down the page. A equals minus 1. Merit. Easy. Here's a nice hard one. Warm up your hand. Look, my camera is so bad you can't even see my hands when I'm rubbing them together like this. Okay. Here's a nice hard one. Tell me if you've got questions on that one there. Not too tricky. Diff and sub. Here is a nice, tricky, ugly one that I like doing. A chemical was slowly leaking onto the floor. The chemical spreads out from the point where blah 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 blah. At a time t after the chemical leak, R is this. Okay, let's write down bits of information as we go. Right? A chemical leaks onto the floor. Let's draw a picture. It's spilling out into a perfect circle. Wow, that's actually not a circle. Right, it's spilling out into a perfect circle where the radius is called R, but the radius is given by this equation, 0.1 t plus 2. Okay, that's really, really small. So let's call it R equals 0.1 t plus 2. Okay, it's a rate of change, but it's a little bit more difficult than that. Rate of change normally just means we just differentiate. It's not too bad, but there's some tricks in here. Right, use calculus obviously to find the rate of change of the area of the circle, so a dash, with respect to time, with radius 10 centimeters. Okay, so we know radius equals 10 centimeters, so R equals 10 at some point. Oh, we've got an equation for R, and we've got R equals 10. let's sub it in. So we've got r equals 0.1 t plus 2. So this is saying as time ticks on, every second the radius can be predicted by this equation. So if it was 1 second, then it would be 0.1 times 1, so 0.1 plus 2. 2.1 would be the radius. If it was 2 seconds, it would be 2.2. 3 seconds, 2.3, and so on and so on. After 10 seconds, 0.1, 10 seconds, the radius is, what's this? 3. 1 plus 2. Is that right? 3. The radius is 3. Oh, I've subbed that in the wrong side, haven't I? Stupid. I don't know why I put t as 10. I've written r as 10 and I put it in as t. Sorry. So 10 equals 0.1 t plus 2. Right? So the radius is changing as we go. We've got time. We can find out at what time is the radius 10. So 8 equals 0.1 t. 8 divided by 0.1 equals t, which equals 80, I think. 8 divided by 0.1. 80. Fantastic. So at 80 seconds, the radius is 10. So we could redraw this picture. 10 at t equals 80. Right? At t equals 80, the radius is 10. All good. Okay, we've got an equation for the area, pi r squared, which we all should hopefully know. Pi r squared, but the problem is, this is the area in terms of the variable r, the variable radius. So we could write this as a in terms of r is pi r squared. A in terms of r is pi r squared. Okay. Is units important? Always. A is pi r squared. AR is pi r squared. But we want the area of the circle with respect to time, or in terms of time. We've got it with respect to r. We want AT. To get AT, we need to replace the r with a t in such a way that it makes sense. But we've got an equation for r that is in terms of t. So we want AT, we've got AR, we've also got r equals 0.1 t plus 2. So we're going to say AT is pi, and instead of r, I'm going to write this whole thing, 0.1 t plus 2 squared. Okay, I've replaced, that looks a little bit ugly. Right, I've replaced r with 0.1 t plus 2. Okay, and now I've got AT. To simplify this, AT is pi. Remember, pi is just a number, it's not a variable, it doesn't change, it's always 3.14 blah 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 blah. So we treat it just like a number, and this is like 0.1 t plus 2 times 0.1 t plus 2. Okay, I don't know how you do your double bracket expand, but you can do it like this. First one squared, or what, 0.1 times 0.1? 0.01? Surely. Yep. 0.01 t squared. First time, second, and double plus 0.4 t last one squared plus 4. Okay. hopefully that that works there. Tell me if I've done my maths wrong, but I think that's right. You could even expand this pi throughout the thing. 0.01 pi t squared plus 0.4 pi t plus 4 pi. Remember, pi is not a variable. Okay, pi is not a variable. Pi is not a variable. So we now need to differentiate this. So we're almost there. We want the rate of change of the area of circle, and we've got the area of the circle. So the rate of change of the area of the circle is differentiating this. A dash t. This is going to be 2 times 0.01, 0.02 pi t plus 0.4 pi. This one disappears and the t drops off. Yeah, Rainy, you're right. 2 pi is the answer. We're almost there. Okay, we've got the rate of change at a time. We want at the radius of 10. We've got the time at radius 10. So a dash 80 equals 0.02 pi 80 plus 0.4 pi. Do all this. A dash 80 equals 2 pi 6.28 centimeters squared per second. Will we be getting the equation templates in the test? What do you mean by equation templates? Like area of the circle? Yeah, I don't think they expect you to know that. Okay. Easy. See you later, fastest noodle. Okay. That's the hardest question. Okay. I think it's the hardest question in the whole paper. Whew, it's a bit tiring. We're at an hour. We're almost we're basically over halfway. So far so good. Let me know if there's any questions with that. Let's check the answer. 2 pi. Perfect. 6.28 is fine too. Okay. This is also a pretty tricky one. Whatever question this was, question 2. All of this question 2 was hard. Right, let's get rid of this. Let's try this last one. Well explained. Thank you, Irina. Appreciate it. Right. Yeah, you think it's tiring? Then go try doing it, mate. Try doing it. Alright? Let's go. E. Dewey calling me out. Relax, Dewey, relax. Okay. Right. A function, blah 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 blah. Let's do it. Y equals 3x3 minus 4a squared x plus 5. Now before I copied this question down before incorrectly, and it gave me a wrong answer. Not good. Find the range of variables x in terms of a blah, 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 for when the function is decreasing. So this is an increasing / decreasing question. Cool, we've identified that and we know how to respond. We double diff and sketch. That's how I respond anyway. Double diff and sketch. Okay, let's work through this. Y dash 9x squared minus, now be careful, this is a squared x. Okay, I have a question. What the heck? Wait, is what the heck the question? What the? Be careful, this is a squared, not x squared. So it's going to be 4a squared and the x drops off when we differentiate. Okay? Fantastic. We've differentiated it once. Now we want to double diff to find out 9x squared. Or actually, I've jumped a step, sorry. Turning point at y dash equals 0. Okay. Difference of 2 squares. No. Don't need to do that. Right? Turning point at y dash is 0, max and min at the double dash things. Right? Let's do this bit by bit. 0 equals 9x squared minus 4a squared. Okay? Now, because there's no other stupid x terms in this question, we don't need to go to our graphics calculator. We can manipulate this, because this whole piece here is just a number. So, this becomes 4a squared over here equals 9x squared. Okay. I can then divide by 9. 4a squared all over 9 equals x squared. And take the square root. But we know we have to plus minus square roots when we do square roots. Now, how's your algebra? This is the question. When we square root a term, let's do it up here even. When we square root x squared, it becomes x. Okay, when you square root x squared, it becomes x. So if we square rooted a squared, it becomes a. If we square root half a squared, then we have to square root the half times by the square root of x squared. So square root of a half times by x is what we're sort of doing. I don't know if I can break that down too much, right? But let's have a look. We square root the numbers, and we do the powers do the power rules. So square root of 4 over 9 is 2 over 3. So we've got plus minus 2 over 3 a, and that square is going to disappear because square rooting a square is like cancelling each other. So we've got plus minus 2 over 3a. Which are our two answers? So let's go up over here. X equals plus 2a over 3, or x equals minus 2a over 3. Nice. Right? Let's find out which one is a max and which one is a min by doing the double derivative test. Y double dash is 18x minus all that stuff disappears. Y double dash is 18x. Right. Thanks, Raina, appreciate it. Y double dash. Now let's just think about this, right? Because the problem is we don't know what A is, right? We don't know what A is, right? But in this situation here, right? We know one bit of information. A is positive. Okay, A is positive. So the sign of this term is not going to change. Right? A can only be 1 all the way through to a bajillion in the positive. So it's not going to change this to a negative. Right? So if this is a positive times the positive, so let's just call this the positive. Right? 18 times some positive is only going to be some greater positive. Okay? Benson burner. Wow. Okay? 18 times some positive is only going to be a positive number. That positive number is guaranteed to be greater than 0. Therefore, that's a minimum. Right? And let's have a look at this. Y double dash is 18 times some negative number. That's how I write negative, right? Negative sign VE, positive sign VE. Right? This up here is only going to be negative. There's no way it can be positive. So when it's times by a negative number, this Y double dash is guaranteed to be negative. If it's guaranteed to be negative, it's going to be smaller than 0. The crocodile will want to eat 0 instead of having its food taken away. Therefore, this is a maximum. Cool. We're like 85% of the way there. Right? Given this bits of information, we know we have a minimum here and a maximum here. Let's plot it on a graph. A minimum at 2 over 3a. Let's call this, sorry, 2a over 3. A minimum. Let's draw a minimum down here. And a maximum at minus 2a over 3. A maximum over here. Now it's an ugly ass drawing, but it will do the trick. Let's connect it. We know it's a cubic. Let's connect it. This is so ugly. We know it's going to look something like this. Now it might look nothing like this, but it might be something. Right? Now the question is, for what range of x values, find the range of values of x in terms of a, so we can leave a in our answer. Find the range of x values which the function is decreasing. Okay, it is decreasing between here and here. This range here is decreasing. Okay, so if that's the range is decreasing between minus 2a over 3 and x and 2a over 3 is where it is decreasing, between those regions. Between those regions it is decreasing. Let's double check our answer. Oh, nice. You can even write it as a word. Decreasing function between that and that. Question for viewers. Right. That's our one there. Looks right. Excellent. Well done. Whew. We're cracking on. That's a tricky one. Right. Now, do you want to skip some of these achieved merits? Or do you want to skip this? I think this is just an achieved question. It's just an anti-diff plus C question. Type skip if you want to skip this and just jump straight to the hard one. I know our brains are hurting. If you want me to do this one nice and slowly, say yep or do. If you want to skip it, write skip in the chat. I'll have a drink. Dewey's saying help us, help us. Does that mean you want to do it, Dewey, or does that mean you want to skip it and do the E? Skip or do, skip or do. Do it, okay, Dewey said do it. Do it, do it, do it. Easy as, no worries. Okay. dy by dx equals 3x squared minus 5. dy by dx is the same thing as y dash, which is the same thing as f dash x. Okay. Oh, the sail on it, erasure. Okay. dy by dx annoys you. Fair enough. It just means y dash or f dash x. Okay, so this is the same as. Now, in any question where they've given us the derivative already, we probably have to anti-diff. So, if we anti-diff this, anti-diff, then y will equal, we add 1 to the power 3, divide by the new power 3. We add x if it's just a number, and then we add our plus c. Don't forget the plus c. I promise one of you will forget it. Do not. Y equals 3 over 3 is x to the 3 minus 5x plus c. The problem is we need to get rid of this plus c. Right? But they've given us these nice friendly points. Right? So x is 1, y is 0. 0 equals 1 to the 3 minus 5, 1 plus c. 0 equals 1 minus 5 plus c. 0 equals minus 4 plus c. C equals 4. If c equals 4, we write our final answer. Y equals x 3 minus 5x plus 4. Whew. Done. Right. Last but definitely not least, we're moving on to some kinematics. Let's double check we got it. Nicely done. I haven't made any mistakes yet. Good. We got this thing. Graph, skip it. Dewey's happy. Where are you taking Air Asia to? That sentence doesn't make sense. Air Asia is, where are you taking Air Asia to? Where am I flying to? Where am I taking? It's like saying, where am I taking Air New Zealand to? Come on, Oreo. Right, kinematics. Here's the tricky stuff. And some people have been saying in chat they find kinematics tricky. This is a hard kinematics question. There's no two ways about it. It is hard. But you guys are smart. I'm reasonably smart. We got this. I've even done it already just to make sure I can do it. So Meg, wretched Meg, is riding her motocross bike. Go Meg. When she passes a fixed point P on the track, she has a speed of V. Blah, 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 blah. Right? When I see these questions, I write down all the bits of information that they've given us in a formula or equation if we can. Basic.exe has stopped working. No, I swear I'm good. Okay, so V is not 0, 5 meters per second at P. A is 0.6 meters per second right, at P. Right, if you're ever in doubt, start from either end of our distance, velocity, acceleration. Okay, don't start in the middle unless they give it to you. So A is 0.6. If she were to accelerate this rate, what would speed be? Blah, blah, blah. Right. I'm just going to write this. AT is 0.6. Our acceleration is 0.6. Which means our velocity versus time, we will need to anti-diff our acceleration to get to velocity. Remember, Diva is the best player in Overwatch. Right, Diva, and we diff. I know I'm writing really small. We diff down as we go down. We diff down the Diva. We go back up. We anti-diff. So if we're going from acceleration to velocity, we anti-diff. To anti-diff this, we would add 1 to the power, or we should use t. Right? And we would plus our c. Right? Point P, let's draw a little diagram. Point P is basically the start of where everything is measured. Right? We would say it's where the distance is 0, where the time is 0. Like someone is standing at point P with a stopwatch and starts as soon as Meg hoons past on a motocross bike. Right? So point P is like our 0, T0. Right? And we know at point P she's already going 5 meters per second. Right? So at T0, P is T0 at point P. So at T0, V is 5. V at time 0 is 0.60 plus C. V at time 0, this piece here, is 5. 5 is 0.6 times 0 plus C. That means C is 5. Okay? Which means our actual equation for Vt is 0.6t plus 5. That's our full equation there. Right? Now we've got this equation, we can start doing stuff. If she were to accelerate this rate, what is her speed when she has been riding for 10 seconds? Okay, Oreo's got to go. No worries, mate. Thank you for tuning in. We're almost finished here anyway. Vt is 0.6t plus 5. At t of 10 seconds, what is her velocity? So, v at 10 is 0.6 times 10 plus 5. V at 10 is 6 plus 5, which is 11. meters per second. Right? I think that's only a mirror. Yeah, 11 meters per second. Okay. The velocity at 10 is 11 meters per second. Right, so far so good. How far, that means distance, how far will she have traveled from P when she reaches a speed of 8 meters per second? Okay, let's find out how long it takes for her to get 8 meters per second. Then we can use time in the distance formula to find out how far she goes. How long it takes for her to get to 8 meters per second. We've got this equation, so let's call this what II. We've got this equation, Vt 0.6 t plus 5. At 8 meters per second, 0.6 t plus 5. Who is able to count when you can play HOTS? Yeah, I'm craving HOTS right now. We're almost finished. Okay. 0.6 t plus 5 minus 5 would be 3 equals 0.6 t. 3 divided by 0.6, I can't do that. 3 divided by 0.6 is 5. So at 5 seconds she is going 8 meters per second. After 5 seconds of leaving P, she's going 8 meters per second. How far is that? Well, we need to get from Vt realm, the velocity realm, to the distance realm. Dt is the antiderivative of Vt. 0.6 t squared over 2 plus 5t plus c. Right? 0.6 t squared over 2 dt, 0.3 t squared plus 5t. Now the plus c, the distance at p, like 0, I should probably just do it. Okay. At the distance of 0, time is 0. To always find c, we need bits of information, right? So I'm just going to create some. At time 0, the distance is 0. We know that. That's almost always a fact, unless you're doing something from a height or something like that. So therefore our c equals 0. So this equation can just be written as dt equals 0.3 t squared plus 5t. Right? We're running out of space. Our time is 5 seconds. Our time is 5 seconds, so d5 is 0.3 5 squared plus 5 okay, and that equals some number. 0.35 squared plus 25 is 32.5. So here's our picture. 32.5 meters, 5 seconds, 8 meters per second. Oh, there's our picture here. Okay, after point P. We're going to need this information for the next question. Last one. Last question. Right, I think that one's an E anyway. Man, the first E's are always easier than the second E. This one's way harder. Okay. I'm going to clear this, but I'm going to redraw that diagram from before. Right, I'm going to write all of our equations. I need to clear it. So V T was 0.6 T plus 5. dt was 0.3 t squared plus, I don't know if we'll need this or not, but I'm just going to write it. And then we had point P after 32.5 meters, they're going 8 meters per second, and it's 5 seconds. Okay, because Meg's friend Leo joins the picture. Leo's riding with her, but begins to decelerate when they reach 8 meters per second. So Leo's riding with her this whole time, and then at this distance here, Leo's starts decelerating. So he's got a new equation. If he decelerates his AT, his deceleration is 0.2. Now if you're decelerating, it's negative acceleration. So I've got to make it negative. Right, and we're going to do a new point here and go from there. AT minus 0.2, let's find his VT. So this is Meg, this is Leo, because he's got a new equation. Anti-diff, this one above, minus 0.2 t plus c. Okay, at time 0, or at time 5, his velocity is 8. Right, at time 5, his velocity is 8. Where's my piece of paper gone? At time 5, his velocity is 8. Let's see if we work. I've looked at it a different way when I did it, but let's see if this works. At time 5, minus 0.25 plus c, his velocity was 8. So I'm going to call it 5 seconds here. You could restart the timer and call it 0, but let's see what happens if we don't. I want to see what happens. V. Oh, this was 8, right? 8 equals minus 0.25 plus c. 8 equals minus, minus 1? No, that's not right. I'm getting tired. Minus 0.2 times 5. Oh, here's minus 1. Minus 1 plus c. Chat's gone quiet. Tell me you're still there, please. 9 equals c. So our other equation, Vt minus 0.2 t plus 9. Whew. Okay, this is Leo's equation for his velocity as he's starting to decelerate from here on in. That's Leo's equation. Right, if that's his velocity equation, how fast, so we want to know what time and then what distance. So if he's gone 6 meters per second, 2t plus 9, then what time is that at? Minus 3 equals minus 0.2 t, right? Divide by this, minus 3 divided by minus 0.2 is 15. So at 15 seconds, he will be at this. Yeah, I know it says c equals 8. Let's see what happens, because I think we're doing something different. We're doing it a little bit different with student. We're doing it different. We're doing it different. Trust me. Look, c equals 9, alternate method. Shouldn't v equal 0.2 x plus 8? No, trust me. Our maths is fine. Our maths is fine. Trust me. Thug life timed out. Jeff, no, that's not what I wanted when I said say something in the chat. Okay, we're almost there. At time 15, Leo is at 6 meters per second. Okay, so the distance he'll be at, well, we're going to have to integrate Vt minus 0.2 t squared over 2 plus 9t plus c. His distance at time 5 is 32 meters. At time 5, his distance is 32. So his distance is 32.5 at time 5. This is minus 0.1. Do we see that? Minus 0.1 times 5 squared plus 9 times 5, 32.5 equals 42.5 plus c, minus 10 equals c. So our dt minus 0.1 t squared plus 9t minus 10. Almost there. His equation for his distance is this. Oh, what happened? No, no, no.